Right, we are now moving on to question number 4. It reads, the diagram shows a container in the form of a right circular cone of height h and radius r. The height of the cone is 10 centimeters and diameter is 2 centimeters. The container catches water, right, from a tap leaking at a constant rate of 0.1. The height and radius are always proportional. Find the rate at which the top surface area of water is increasing when the water is halfway up the cone. 9 marks. Right. So, our starting point is height and radius are always proportional. So, let us apply the variation concept. If height and radius are always proportional, it means h is proportional to r, then you put equal sign, then you multiply the right side with the constant of proportionality, which is k. Right. So, height is equal to 10 centimeters when diameter is equal to 2 centimeters. So, if diameter is equal to 2 centimeters, it simply means that radius is equal to 1 centimeter, since radius is half diameter. So I'm going to put 10 on h. I hope you are following. Then I'm going to put 1 on r. So 1 times k, you get k. It means k is equal to 10. I hope you are following. Right. So if k is 10, h is equal to 10r. So this result is very, very important in our journey. Right. So, differential coefficients of volume, I'm going to place them on my left side, and differential coefficients of area, I'm going to place them on my right side. So, the first differential coefficient of volume is going to be generated by the words catches water. Right. So, the cone is catching water from a tap leaking at a constant rate of 0.1. I want you to understand something here. The cone is not the one which is leaking, right? But there is a tap which is leaking, and the water which is leaking from the tap is entering into the cone. Hence, the cone is receiving, right? So, catches water, it means the rate of increase of water in the cone with respect to time. And the differential coefficient for catches water is dV/dt, and it is a positive differential coefficient. Why? Because the volume in the cone is increasing, right, by receiving the water which is leaking from the tap. I hope you are getting me, class, right? So, the rate at which the tap is leaking is good as the rate at which the water is entering in the cone. So, if the tap is leaking at 0.1, it means the cone is also receiving at 0.1. Take note of that. Right. Then another differential coefficient is going to be generated from the question itself. Find the rate at which the top surface area of water is increasing. So we refer to this as dA over dt, the rate at which the top surface area of water is increasing. So this one is unknown. This is our target. If we are to find this, you get yourself 9 marks. Right. When the water is halfway up the cone, right? It is very important. When water, right, is halfway up the cone. Take note of this crucial statement, right? So, what I want you to do now is, we need to create another differential coefficient on the volume side. This is achieved by writing the formula for the volume of the cone, which is 1/3 pi r squared times height. After that, you need to remove this h and replace this h with the 10r. Remember, h is equal to 10r from the proportion, right? So I'm going to put 1/3 pi r squared, then you put 10 r on h, something like this. So if you multiply, you get 10 over 3 pi r cubed, which is your volume, right? So the next differential coefficient is dv dr, which is going to be generated by differentiating the right side. So 3 is going to multiply 10 over 3 pi. Then you less 3 with 1, you'll be left with the 2. You can clearly notice that 3 and 3, they cancel out each other, giving you dv dr is equals to 10 pi r squared, which is the differential coefficient generated from the volume side. I hope you are listening, class. We also need to generate another differential coefficient from the area side by understanding that find the rate at which the top surface area of water. So the top surface area of water is in the form of a circle. I hope you are listening. So area is going to be represented by pi r squared, which is the area of a circle, as a circle is being formed on the top surface of the cone. I hope you are listening, class. So I'm going to find dA dr. So 2 times pi, you get 2 pi. Then less 2 with 1, you get 2 pi r. I hope you are listening. Right. Remember, our target is to find dA dt. Right. So to find dA dt, you make use of chain rule. Right. For the chain rule, you are going to say dA dt is equals to dA over dr times dr over dv times dv over dt. Why? Because you can clearly notice that dr and dr, they cancel off each other, dv and dv, they cancel off each other, and you'll be left with the dA and dt, giving you the requirement, which is the rate of increase of area of the top surface with respect to time. I hope you are listening. Right. So we want to substitute the differential coefficient that we have obtained in this chain rule. The first differential coefficient is dA dr. So dA dr is 2 pi r. I'm going to put 2 pi r on dA dr, then you multiply. Right. The next is dr dv. So dr dv is going to be obtained by reciprocating dv dr. So if dv dr was 10 pi r squared, it means dr dv is 1 over 10 pi r squared. I hope you are listening. Then we now need dv dt. So dv dt was generated from the words catches water, as the cone is receiving water from the tap, which is leaking at a constant rate of 0.1. It means the cone was increasing in volume with the 0.1. So dv dt is going to be taken as it is, 0.1, but 0.1 can be written as 1 over 10. I hope you are listening. Right. So you can clearly notice that pi is a factor of pi. So pi and pi, they cancel off each other. 2 is a factor of 10. So 2 into 10, you get 5. R is a factor of r squared. R into r squared, you get r. I hope you are listening. So 1 times 1, you get 1. 5 times 10, it's 50. But remember, we still have this r. So the rate of increase of the top surface area with respect to time is 1 over 50 r. Right. But remember, there was a statement when the water is halfway up the cone. Remember, the height of the cone is 10 centimeters from the bottom to the top. So the water is going to be halfway up the cone when the height of the cone is 5 centimeters. I hope you are listening. Right. But if the question says find the rate at which the top surface area is increasing when the cone is half full. For such a question, you start by calculating the total volume when the cone is full. You write a third of pi r squared h, something like this. Then you say V is equals to 1 over 3 pi. Remember, 1 is the radius, right? Then h is the height. So if you use height of 10 and radius of 1, you get the total volume when the cone is full. And the total volume when the cone is full is going to become 10 over 3 pi. That's the total volume when the tank is full. Then you multiply this by half. So if you multiply this by half, it means if the cone is half full, you get 5 over 3 pi cubic centimeters in terms of volume, right? Then to find radius, you then need to go back to the left side where we replaced h with the 10r. We got v is equals to 10 over 3 pi r cubed. So you say 5 over 3 pi is equals to 10 over 3 pi r cubed. You can clearly notice that pi and pi, they cancel off each other. 3 and 3, they cancel off each other. If you divide both sides by 10, you get half is equals to r cubed. It means cube root of half is equals to r. So this is the radius that you use if the question states that find when the cone is half full. You replace this r right in front of this 50 with cube root of half to find your final answer, right? But the question here is asking otherwise, right? Find the rate at which the top surface area of water is increasing when the water is halfway up the cone. Up the cone, it means that we are concerned about the height only, not about the capacity, right? So up the cone, from the bottom of the cone to the maximum point of the cone, we have 10 centimeters. So halfway, it means 5 centimeters. So I would like to find when the height is 5. I hope you are listening. So when the height is 5, you go back to this proportion, put 5 on h, you get 5 is equals to 10r, divide both sides by 10, you get 1 over 2 is equals to r. So I would like to find when r is half. So I'm going to put half on r, you get 1 over 50, open bracket, 1 over 2. So 50 times half is 25, and this is your final answer. 1 over 25 is the rate at which the top surface area of water is increasing with respect to time when the water is halfway up the cone. And halfway up the cone is when the radius is half.